Hi, and welcome back to HeFPipe. Today we're going to talk about the regression analyses. Last time we talked about running the single locus effect F ratio test, which you can see we skipped in this run of the pipeline. And the next prompt of the pipeline is whether we want to run the regression test. So we're going to hit yes. And basically the regression tests mean that you can regress any trait on any other trait or combination of traits, including the addition of interaction terms in the dataset. So less broadly, this portion of the pipeline is intended to act as the heterozygosity-fitness correlation part, since HFCs are actually regressions. So the regression module is divided into three components. The first is a full dataset regression, the second is data subset regressions, and the third is user-generated data subset regressions. Now the pipeline asks whether you want to run regression analyses, like we have covered already, and it will allow you to opt in or out of each of the three components in order. So you'll notice we're about to opt into the first component. And for the remainder of this video, we're going to talk only about the full dataset regressions, that first component. So in the full dataset component, you're provided with a list of fitness variables in the dataset, and you can see those listed here. And before typing the response variable that you desire for this particular model, you're prompted to type the error distribution associated with the distribution of that response variable. And you can refer to the previous video about single locus associations for details about what I mean by error distributions. But let's go through an example. Let's say I want to run a regression using survived occlusion as the response variable. And I know that that's a binary trait, so I type binomial here as my error distribution. You're then prompted to type the response variable. So you type the name and then you press enter, and the pipeline is going to throw an error if you type a trait that does not exist in the data set. So for example, if you've made a spelling mistake, and it asks you to retype it. So there's sort of built-in spell checking here. So we'll type in survived occlusion here. And then you're prompted to enter predictor variables, and you're free to type as many of these as are relevant. Multilocus heterozygosity, or one of the estimators of multilocus heterozygosity, is of course the most relevant for HFC studies, but you can do any permutation of any of the traits as predictors that makes sense. And you press enter between each entry. So the pipeline also accommodates interaction terms here, and the syntax is of course the same as it is in R. So for example, let's say I want to use MLH and PC1 as predictors, and I want to also enter the interaction between those two variables as a predictor. I would just type MLH star PC1 which we'll get to in a second. And when you're done entering all of the predictors, you just type done when you're done. So let's run through an example here. I definitely want MLH as one of my predictors of whether the queen survived occlusion, right? Whether, this fitness trait is predicted by multilocus heterozygosity. I also, just for the fun of it, want to see whether PC1 also plays a role, and I also am curious about the interaction between these two traits. So those are the three predictors. I press enter in between each one that I typed in, and when I'm done, I just type done, and it runs the regression for me. So at this point, the module generates three files in a regression subdirectory in the pipeline directory. So let's go to the regression subdirectory, which gets created if it didn't already exist. And then we'll take a look at the three files. We're ignoring completely this file called temp. So the first file is called the family of error distribution plus the response variable on the predictor variable or variables, and then full dataset assumptions check.tiff. Okay, so that's clearly this first one. Binomial is the error distribution. Survived occlusion is the response variable on, and then the list of all of the predictor variables, and then full data set assumptions check.tif. And this contains plots that can help you decide whether the assumptions of linear regression are satisfied for the particular model that you're dealing with at this point. You should also bear in mind that interpretation of some of these plots that use non-Gaussian error distributions undergo transformations, and the regression coefficients won't have a direct biological interpretation, and neither will these plots. So bear in mind that it's possible that these plots will look a little funny because of the nature of the response variable. The second file is called response variable name on predictor variable name full dataset.txt. And that's here. And inside of it lists the regression statistics exactly as if the GLM, or generalized linear model function, had been called in R. So the output looks exactly the same as it would in a GLM call for R. So the p-values for all of the different predictor variables are listed here, as well as the regression coefficients, standard error, and the z-scores. So that's what the second file looks like. The third file is called response variable on predictor variable or variables. So here's the response variable on predictor variables .text. And it applies the Akaike information criteria, or AIC, to the full data set, exactly as if the step function had been called in R. So then you're asked whether you want to run another model, and let's say that in our case we do. And we type yes or Y, and we repeat the whole procedure, which is to say that we're allowed to select other response and or predictor variables in a new model. So this time, let's say we want to look at initial queen weight, which is queen weight initial here, as the response variable, and I know that that has a Gaussian or normal distribution. I just type Gaussian here and hit enter. And then we type queen weight initial as the response variable. And then it asks us again which predictor variables, and let's say again we want to use MLH, PC1, Cove, and then an interaction between the two of them. We type those three variables and then we type done and hit enter. And again we'll see the new output has been generated here. This time Gaussian, queen weight initial on all the same. And you can see in this case the assumptions seem to be met pretty satisfactorily. None of the variables are retained as significant predictors, and the AIC analysis is applied as well. Now let's say we are done with running the regression models, then we would not want to run a different model, and we type no. And we move on to the next of the three optional components of the regression analyses. Stay tuned.